All right, here is the video for Engineering 305 for the FEA part of the course. This is the how-to video for week 3, which is going to walk us through Solidworks for how we create a structure and a load. And we're going to do a very simple structure, but it will get you through really the week 3 exercise. So we're going to start with, I'm going to hit File and New, and I'm checking out the screen, and yep, you can see my mouse a little smaller than normal. Doesn't have a tail on it. Maybe I should fix that, but we're going to plug right through. I'm going to start with a new part, so I double clicked on that. Going to take a second to come up. Hopefully not much longer than a second. Hopefully not much longer than a second. So one of the things I've had to do to get the software to run has been to turn off my graphics card adapter, my fast graphics card adapter, and run just on the slow one. And that is causing a fair number of issues or speed issues, but that's okay. We'll get there. So I'm going to grab the top plane. Actually, I'm going to start from the bottom of the part and extrude it up. What I'm going to do is just make a long bar, same as the other video. And it is going to be, I'm going to put one corner at the origin. I'm always kind of specific about some things for having them tied down. And I am going to make this, I'm going to make this 0.333 wide. And it is going to be 3 inches across. And the reason for that now is that is going, if I multiply those together to calculate my area, it is 1 square unit, but I'm drawing in inches, so it's 1 square inch. And then I'm going to extrude that in the plus Y direction. I'm going to extrude that 6 inches, which is what I did in the inventor video. And there's our block. And now I have been having so many problems with what we're doing that I'm going to just save this a sec because I'm expecting it to crash because nothing has worked today. Poll test 1. I got to pick a better spot. Documents Kelvin. Let's put in a new folder. 5. I just took it there for right now. Maybe I'll move it later. It's ready. And so then what you have to do, and your tab may or may not be loaded, but it's the simulation tab up here. And it might not be loaded. So I'm going to show you. If you hit the tools and then hit options, no, it's not going to be that. I always forget this one. I don't think this is it. Nope, it's not that. It's an add-in. Tools add-ins. There we go. And you can see the simulation box is checked for me, and it fires up at startup. If that's not checked, then you have to open this add-in and you have to check at least that one, and that will allow it to load up. And it takes 3 seconds. That slows up my start time every time. That's why I don't have any of these other things done. I'm not doing circuit work regularly. I don't do photo view. I do some FEA. So for 3 seconds at startup, that's okay. You can see some of these other ones that I don't have too, but that's the way to get it to initialize. So then you can pull down that simulation tab and you hit study, and that's going to give us this menu that says you're going to launch a new study. What kind of study are you going to do? Well, here's the name, static one, that's fine. But then it can either be a general static study, or it could be any one of these different things. So it's, let's see. Yeah, oh, sorry. I own this copy of the software. I don't have all of the options because I can't afford them. And I don't have a student version installed, so this is what I get to show you on. So the only thing I can do on this computer is a static study, which should be good for everything we do this semester. Although playing around with some of the other stuff is a lot of fun, and Professor Han would love you to work on modal stuff. But I'm good with the static study. So I checked that box and then I hit OK. And now, like Inventor, we're going to walk from left to right across the menu system to get our steps right. So we just did the new study and we defined it. Now we have to apply a material. And so I can do that. Oh, I can left click on that and there comes the menu. And I'm going to pick I'm going to pick an alloy 1010 steel. And you can see that's kind of I can't tell there. That's in pascals. I don't know that. I want to do this in English. So there's a 29 million psi, 29 E6. That's about 30 E6, which is what I would want to use. And then I've got shear modulus, density. I've got a yield strength, which is really low at 26,000. That's really pretty questionable steel. I could go to a 1020, which is going to be the same modulus elasticity. We can talk about that. Now my yield got a lot better, 50,000. It's fine. Pick either a 1010 or a 1015. Let's 1015. Tensile strength 55. Let's just stick with a 1010. It's close to what we were using in Inventor. So I hit apply and then it doesn't do anything. It applied it. Now I have to close the menu. I'm going to close the menu and then I'm walking across. New study. I applied the material. Now I got to put a fixture. And what they mean, how is your structure fixed? And so I'm I you have to select the down arrow and say you can use the advisor. I don't like the advisor. I'm going to just put fixed geometry. This bottom face is fixed. You can see I grabbed that. I'm all set. And here's a little picture to kind of tell you what's going to happen. That face does not move. Okay, that's good. And then I need to put on an external load, and I'm going to put that on this face. Oh, that's the external load advisor. Click the down arrow and put on a force. And I selected the face already. I don't want it to be in compression. So I want to hit the reverse direction. And then I got to put that on in units. And I'm going to do this. It's in English. And I'm going to put on 15,000 pounds. Same, you pick 15,000, same load I put on before in Inventor. Boom, done. Now I can do connection advisor connections, and I can talk about how my connections go together, but this is not a assembly. This is simply a single part, so there's nothing there. And then shell manager, I don't have to mess with that. I'm really done. I can hit run this study at this point. So when I hit that, it's going to mesh it, going to do that, going to think about it, and it's solving it. I can look at more, but by the time I do, it's done because this is a simple problem. You can see it's pushing up and it grew and it kicked out a number of charts. This is different than a little different than Inventor, but I can show my stresses, and my stresses look like that. If you looked at the Inventor video, you'll recognize I have some low stresses in the middle, some high stresses on the corner. They're both getting the same result. However, this is confusing because this is in pascals, which is not what we want. We want this in English units. So I am going to, if I right click on that, I double clicked on it, and yeah, it's bringing up my chart options. So I'm going to go to settings, definition, and I'm going to change my units to PSI. I don't know how the computers at Calvin will be configured, but there's our peak stress right at that corner, 24,000. At the middle, it's not quite as high, 8,000. And then the rest of this model is green, and the green corresponds somewhere in this range. Now, what do we know? What do we know that stress is? It's 15,000 pounds divided by 1 inch of cross-sectional area. So the stress should be 15,000. If I go to plot tools and look at probe, then I can pick a spot here, and it tells me that the stress is 15,040 PSI. Or here, where it's 1501, or here, where it's 1500 exact, or here, where it's 1501. We're getting, I'm going to guess we got just a little bit of round off air, a little low there, a little higher there, a little low here, I'm sure. Yeah, 1304, because that's getting close to that. You're starting to see where that stress is. And I know how to do this for SolidWorks. I'm going to turn off the probe. They all go away. If I double click on the von Mises stress, if I double click on the color bar again, I can do chart options. And instead of having this be automatic, I can say my maximum stress, I want it to be at 15,100. And let's make this 14,900. So now it's what I expect, 15,000 plus or minus 100. And you can see that's what I'm seeing. I've got some problems that are created by where I held it, and that creates some problems along the side. But once I get a significant distance away from that, things start to settle out. That's what I expect to see. I can do a better job. So there you go. There's our video. You're all done. Have a great day. But if you stick around for after the credits, what I'm going to say is we can get better results. If I go to the mesh advisor, if I turn this on, oh, not the mesh advisor. I never want the advisor. I want to just do it. So create a mesh. And then this is it says you're going to get all new results. This used a medium mesh. If I go to a fine mesh, and then I just hit run this to solve it. Now I hit go, and it's going to redo the analysis. I should get better results. It should limit these errors down to the bottom a little bit more, but not necessarily. But it's going to take longer to solve, and you're going to see that as we wait and wait and wait and wait. No, it didn't. It limited. Yeah, it kept it pretty much the same, maybe a little bit smaller. Maybe a little bit smaller. There are reasons for that. I can give you another video to show you another way to improve on that. But that's for the advanced stuff. We've got the basics covered right now. I hope you're doing well and you enjoyed this. See you.